Good evening. Welcome for some more sleepy math. Hopefully you can hear the rain that's going on outside. That ought to help put you to sleep. Nothing quite like a rainy day and graphing some sinusoids. If you recall, or if you have not learned before, graphing sinusoids can be a little bit tricky, but hopefully I have some tricks of your own, that you can use your own, I should say, that'll make things maybe a little bit easier. So let's start with the very basic ones. F of x is equal to sine of x, as well as f of x is equal to cosine of x. These are our base graphs, and they help us do every variation thereof. So usually when we're graphing a sinusoid, we do the first and fourth quadrant of our x-axes, and you can still identify where the origin is, but instead of going 0, 1, 2, 3, and so on for x, and y, and -1, -2, -3, and so on for our negative x and negative y. We're really just going to focus on the y values of 1 and -1, which you will later hear me refer to as high and low. For our x values, if we are starting at 0, what we really need is 4 hash marks. One complete cycle of a sine wave goes from 0 to 2 pi. So I like to have my 0, which is the origin, and 2 pi at the end of the graph that I sketched. Eyeball the midway point, that's pi, and then cut each of those remaining segments in half. We'll call them pi over 2, and 3 pi over 2. Now, the way sine graphs work, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and sine of 2 pi is 0 again. However, since we are intending to build on these, I actually want to refer to it as mid, high, mid, low, mid. In this case, the midline is the x-axis, which is y is equal to 0. My high is 1, mid, low at -1, mid. So going from left to right, it goes mid, high, mid, low, mid. And I just draw my best sketch through those. And there we go. There's a perfectly serviceable sine wave. Now, if I want to do cosine of x, it's the same setup, just our pattern is going to be a little bit different. So we're still going from -1 to +1 on the y-axis, going from 0 to 2 pi on the x-axis. Looks like I made this one a little shorter, that's okay. And we have all of our core points. Okay, so when you've properly set up a graph for the graphing of one sinusoid, you should have 5 points. Now you might look at this and say, isn't that 4? Well, it's 4 segments, 5 points. Sine went mid, high, mid, low, mid. Cosine starts high and ends high, and it goes high, mid, low, mid, high. So I'm going to graph high, mid, low, mid, high. And if you didn't know what a sinusoid looked like, you might want to try and draw like a V shape through there. It would look like an absolute value graph. That's not what's going on here. So we need to understand that cosine's got some more curvature than that. And there we go. There's a halfway decent cosine curve. Now, the reason why I said high, mid, low, mid, high is our sinusoids can also have various transformations. So let's start with a relatively simple one of f of x is equal to 2 sine of x. And 2 sine of x changes the amplitude. So instead of going from 0 to 1 and -1, really, I need to go up to 2 and down to -2. I'm not going to label my x this time if that's okay with everybody. So when I graphed my first sine wave, I did mid, high, mid, low, mid, and I'm going to do the same thing again. The only difference is my high value is now 2 instead of 1. So mid, high, mid, low, mid. And it looks very similar. Had I stretched it out and kept more or less the same scale as the previous graph, you would have seen it look a little bit taller and a little bit deeper in this part of the graph right here. But I scaled it down, and we're going to have to live with that because it's already on whiteboard and you can't erase that. All right, let's look at a vertical shift as well. So let's go back to cosines. Let's do f of x is equal to, let's do a -3. Cosine of x plus 2. So the -3 also reverses the shape. Cosine goes high, mid, low, mid, high. Because it is a negative cosine, we are going to go low, mid, high, mid, low. I have an amplitude of 3, and that plus 2 just means shift everything up 2 units. So if this is my origin, I know everything's going to be shifted up 2 units from there. So 1, 2. So I'm actually going to erase, if I can find the eraser, there we go. I'm going to erase this line. Even though that is where the x-axis is, I actually want 2, y is equal to 2, to be my midline. So I'm going to draw a dotted line here. Because I have an amplitude of 3, my cosine wave can go as many as 3 units above this line and as many as 3 units below this line. I have already indicated 3 units above, which is 5. I have not indicated 3 units below, which is -1. And I still want to go all the way to 2 pi. And there's pi over 2, and 3 pi over 2. And I just thought of something I can change my color. So there's my x-axis back in there. I think that makes it look a little bit nicer anyway. Let's do our cosine wave in green. So cosine, we said, goes high, mid, low, mid, high. But because it's negative, we're actually going to go low, mid, high, mid, low. And if you have to do multiple repeats of this pattern, you just keep doing that over and over and over again. We're graphing just one wave here. And there's a cosine with a negative in front, an amplitude, and a vertical shift. We are going to look at phase shift and period or frequency with our last example here. So let's go back to sines, and we're just going to put everything that I can think of to put in there. So we're going to have f of x is equal to, how about 1.5 sine of 2 parentheses x minus pi over 4. Now, for those of you who have done this before, or maybe for those of you who are seeing this for the first time, you might look at this question and think, what kind of nightmare is this? Well, if we set everything up properly, it's really not that bad. I'm just going to start by drawing my axes. I have I forgot the phase shift. Let's make this question even more complicated. Let's do minus 0.5. So my x-axis goes there. I still have my origin. I'm going to go to 2 pi. And in fact, I probably shouldn't have done that because I forgot one thing we added to this. We added a phase shift. So what a phase shift does is it moves everything to the left or to the right. And the reason it's called a phase shift is, let's say you had a normal sine wave and you just added 2 pi to all of your x values. It's going to look exactly the same. If you subtract 2 pi from all of your x values, it's going to look exactly the same. There's a lot of ways that you can get it back to where it was. It just kind of changes where our sine wave starts. And the easiest way to figure this out is to look at what's going on right there. Negative pi over 4. I have a phrase that I like to use in my classes that goes well beyond trigonometry. And the phrase is, what makes it 0? Meaning, if I extend this, what value of x makes this expression 0? Pi over 4. Well, then guess what? Pi over 4 is our starting point. So I'm going to put pi over 4 here. And the way that works is if I was to plug in pi over 4 in for x, then I'm doing sine of 2 times 0, which is still a sine of 0, and sine of 0 is where we want our starting point to be. The other part of this is our frequency. One good way of looking at this is how many times does this sine wave appear over the course from 0 to 2 pi. It's 2, so I should have 2 sine waves. Now I said I only want to draw 1, so the other thing we can think of is doing the period, and the period formula is P is equal to 2 pi divided by B, and this right here, this number that stands in front of the x but outside parentheses in this case, that is your B term, and it's 2, so let's change that B. Oops, I'll do it this way. I'm not going to let me delete anymore. Oh, I did my formula. Oops. Oh well. It's just 2 pi over 2, which means pi. So one complete cycle of this heavily shifted sine wave is going to be pi. It's going to cover pi units along the x-axis. Well, I'm starting at pi over 4, and what that means is I have to end at 5 pi over 4. And what I like to do is figure out, well, what's the midway between pi over 4 and 5 pi over 4? You can actually do the math, or you can just look at that and say, well, that's 3 pi over 4. And halfway between pi over 4 and 3 pi over 4 is 2 pi over 4, also known as pi over 2. And then halfway between 3 pi over 4 and 5 pi over 4 is 4 pi over 4, better known as pi. Okay, so I have my x-axis all set up. Now I need to set up my y-axis. Last time I used blue as the x-axis. I probably should have used it for the midline, but I can do it correctly this time. So let's make this right here 0.5. Should be negative 0.5. If I draw a dotted line at negative 0.5, this is my midline. If it helps, you can also draw dotted lines at your high line and your low line. My amplitude is 1.5, so if I add 1.5 to negative 0.5, that's 1. And if I subtract 1.5 from negative 0.5, I get negative 2. And let's use green again, because it's all over except for the fun part. It's a sine wave, so mid, high, low, mid, high. I think I said that wrong. Mid, high, mid, low, mid. I got it right that time. Mid, high, mid, low, mid. Draw your best curve. And there you go. It took a long time. I'm not going to act like it didn't. But was it really that difficult? Well, no. If you take it one step at a time and make sure your framework is correct, the actual graphing is pretty easy. So hopefully you're asleep. If you're not asleep, I hope you learned something. And if you are asleep or you learned something, I hope that you'll take the time to subscribe to my channel and perhaps share this video with your friends. Thanks, and have a great rest of your day or evening or whatever time of day it happens to be. So long.